Good morning, this is Mr. Morales, and these are our notes on quadratic functions. So today, our notes are on page 41, 42, and we begin this lesson now with the standard form of a quadratic function. And by now you've noticed that we have a lot of standard forms. When we do like a basic line, we have y equals x. When we do slope-intercept, it's y equals mx plus b. Standard form of a quadratic, in this case, is f of x equals ax squared plus bx plus c. So as long as you have the highest exponent of a 2, then you have automatically a quadratic. And it's nice to have everything in order with the highest exponent first, and then just your variable, and then a constant at the end, or just some random number. Now these graphs that we're going to make are going to be horseshoe-shaped graphs called parabolas. And each parabola, like the example down here below, has a point where it either gets to a lowest or a highest, or in other words, a minimum or a maximum value. That point is called a vertex. And the definition we give is it's the point where the graph changes direction. For example, this graph down here, it curves from left to right. It's going down, down, down. It hits the vertex down here, and then it swings back up again. So at the point where it switches directions, that point is identified as the vertex. And on the side of my notes, I wrote sometimes also referred to as a maximum or a minimum, depending on which way your graph is facing. Next, we have what are called the roots. And you know in algebra, we like to give the same thing a bunch of different names, and this is no exception. So the roots are also called your x-intercepts, also called or referred to as your zeros. So there's 3 names for the same thing. And what they all describe is basically where your graph hits the x-axis. So basically right here. Whatever those values are, or those factors in some cases, those are your roots or your x-intercepts or your zeros. Make sure you know how to use all those words interchangeably at any given time, because they can be used whenever. Next, we have what's called the line of symmetry. That would be the line that if you drew it, it would cut your parabola right through the middle in equal mirror halves, the left and the right half. And that line of symmetry actually has an equation. And just like our standard form has a, b, and c, you can take these coefficients or this number at the end and plug it into this formula, negative b over 2a, and you'll get a line, an x equals line, which means the line that goes, vertically up and down. I get those confused sometimes, hence the pause. Up and down. So in this case, we'd have a line that goes right through the vertex and cuts this graph in half. And that equation is given right here, although we won't be using it too much today because a lot of times it's very obvious visually, so you won't need the equation so much. But there it is in case you want to calculate it at some point. So my notes are a little piecewise because I'm breaking it up into sections, and I do apologize in advance for my computer that cuts the videos off midway through discussion. Maybe I'll get a Patreon at some point and get a better laptop. So here we go with our graph. Don't get overwhelmed with the graph just yet. Let me explain it, and then feel free to write everything down. So it says the vocabulary for the quadratics unit. The graph of a quadratic function is a parabola. Once again, it's stated right here. It looks like it's read as parabola, but it's pronounced parabola, generally speaking. And let's break it down to a couple of its components. First of all, we have root number 1. That's also the x-intercept, and that happens if you can't read, and this graph is a bit faded. It hits the x-axis at -2, or if you wanted coordinates, you could say -2, 0. Parabolas generally have 2 roots. In this case, we have the one over here on the positive side, and that is at where x equals +4, or the coordinates 4, 0. Now, the roots don't have to always be negative and then positive. They can be both negative or both positive, depending on where your parabola is located in your coordinate plane. But this is just the general idea. Next, I have our y-intercept. Notice this parabola hits the y-axis at -8, or the coordinates would be at 0, -8. Yet that's not the lowest point. The lowest point, or a minimum, is here identified as the vertex of 1, -9. So notice I use the word minimum and vertex to describe the same exact thing. These words are very interchangeable, so you must get used to that. And then, of course, there's our second root, or x-intercept, as we talked about earlier. Now I'm going to talk about the line of symmetry. And in green down the middle, I have this vertical line that goes straight down, and it actually passes through the vertex at x equals 1 is where it hits the x-axis. And that is the equation of the line that cuts this parabola into equal halves. So now we have 2 pieces left, and that is the domain and range, because these things will never stop haunting us forever in algebra. Now, if you notice my graph, I added arrow tips. That's because parabolas, unless they're given a specific scenario, will continue going on infinitely, and they do spread out left and right and continue in whatever direction they're facing, up or down. So in this case, the domain would be all real numbers because this parabola will continue infinitely spreading left and right, maybe slowly, but it will continue spreading. So all real numbers, at some point, it'll hit every number left and right of the number line. As far as its range, well, because it has a minimum value, it will not hit anything lower than -8, because that's where it's, the -9, because that's where its vertex is. And I should change that to make my notes a little more accurate. There we go. So at -9, the lowest y value in this case. So and it does make contact, so y is everything greater than or equal to -9. That means from -9 on up infinitely, this graph will exist. Nothing lower than -9 because it doesn't go down here. It hits a minimum or bottoms out down here. So that's your second part. Feel free to pause this as needed to write down the information. Moving on to the next part. So now we have some calculator work. Once again, let me explain before you start writing anything down. We're asked to complete the table using the equation f of x equals x squared plus 2x minus 15. And I'm going to go ahead and use one of our calculators right now to go ahead and graph this, because this is what you'll be doing mostly. So on my calculator, I went ahead and went to the graphing side, and I graphed this equation. It's already in f of x form, so all I did was type in the equation x squared plus 2x minus 15, press enter. Now, I know I can't see the full entirety of the graph, but I really don't need to at this point, because the instructions ask me to go ahead and fill out the table. So to get a table,